Hello, everyone. In the last class, we learned about the setting principles and requirements for deformation joints. In this class, we will study the construction and methods of the three types of deformation joints. I hope students can grasp the construction and practice of deformation joints. The setting of deformation joints actually divides the building into several independent units structurally. But from the building's perspective, they still form a whole. To prevent rain, wind, air, dust, and other elements from entering the interior, affecting the normal use and durability of the building, as well as to maintain the building's aesthetics, it is necessary to cover and decorate the deformation joints. These operations must ensure that the horizontal and vertical relative displacements and deformations on both sides of the deformation joints are not restricted. During the use of a building, the deformation joint should be covered, and the form of the cover must correspond to the type of deformation. The cover forms for expansion joints, settlement joints, and seismic joints are as shown in the diagram. Next, we will study the construction of deformation joints in walls, floors, roofs, and foundations, respectively. First, deformation joints in walls. Based on the thickness of the wall, deformation joints in walls can be constructed as flat joints, staggered joints, or tongue and groove joints. The advantages of staggered joints and tongue and groove joints are that they help prevent the ingress of rainwater. However, under seismic conditions, the joint parts of staggered joints and tongue and groove joints are prone to damage, which can affect the deformation of the building. Therefore, flat joints should be used for seismic joints, and staggered joints and tongue and groove joints should not be adopted. The exterior wall expansion joint should be filled with elastic materials that possess waterproofing, thermal insulation, and fire-resistant properties, such as asphalt oakum, foam plastic strips, rubber strips, and grease. The interior side of the joint is usually covered with wooden cover strips, metal sheets, or plastic sheets that have a certain decorative effect. The settlement joint in the wall generally serves the dual purpose of an expansion joint. Its construction is basically the same as that of an expansion joint, except that the adjustable cover strip should be structurally designed to ensure that both sides of the wall can freely deform in both horizontal and vertical directions. The construction of seismic joints in walls is basically the same as that of expansion joints and settlement joints. Considering the relatively large width of seismic joints, more attention should be paid to the firmness of the cover joint and protection against wind and rain in terms of construction. For outer joints in cold regions, elastic materials such as soft PVC foam plastic or polystyrene foam plastic and other insulation materials should be used for filling. Second, deformation joints in floors. The arrangement of deformation joints, including expansion joints, settlement joints, and seismic joints in floors, should be consistent with the locations of the corresponding structural deformation joints. Generally, they run through all layers of the floor. Elastic materials such as grease or asphalt oakum are used for caulking within the joints. The surface layer and ceiling should be equipped with cover strips that do not hinder the deformation needed between components. The form and color of the cover strips should be coordinated with the interior decoration. Third, roof deformation joint. The location and width of the roof deformation joint should be consistent with the expansion joints. On the walls and floors, the principle of structural treatment is to neither restrict the deformation of the roof, nor allow rainwater and snow to penetrate indoors, as the area around deformation joints is often prone to roof leakage. Materials such as metal adjusting strips and asphalt jute are used for caulking or covering the gaps within the roof deformation joint. During design, deformation joints can be set on roofs of the same height, within the same floor, or at the junction of roofs of different heights. For roofs of the same height within the same floor, the structural approach differs based on whether the roof is accessible or inaccessible. For deformation joints on inaccessible roofs, generally, a low wall with a thickness of half a brick is constructed on each side of the joint. Proper structural treatment should be done for roof waterproofing and flashing. The top of the low wall is covered with galvanized thin steel plates or reinforced concrete cover plates to cover the joint. A roof that is accessible to facilitate walking. Low walls are generally not constructed on both sides of the joint. In this case, proper roof waterproofing measures should be taken to prevent rainwater infiltration. At the deformation joint where roofs of different heights meet, a low wall with a thickness of half a brick should be constructed on the lower roof panel, leaving a gap between it and the higher wall. Proper waterproofing and flashing treatments should be implemented on the roof. The low wall can be covered with a reinforced concrete slab cantilevered from the higher wall or with galvanized steel sheeting to cover the joint gap. For rigid roofs, the construction of waterproof deformation joints is generally similar to that of flexible waterproof roofs, with the only difference being the type of waterproofing material used. Fourth, foundation deformation joints. There are three structural treatment methods for foundation settlement joints: the double wall method, the cantilever beam method, and the cross method. The double wall method is simple in construction and relatively low in cost, but it is prone to issues such as large gaps between the two walls or eccentric compression of the foundation. Therefore, it is commonly used in buildings with smaller foundation loads. The cantilever beam treatment method involves constructing the wall and foundation on one side of the settlement joint, according to standard practices, while on the other side, a cantilever beam is employed to support the foundation beam, upon which a newly constructed wall is then supported. Using lightweight walls can reduce the load borne by the cantilever beam, but the bottom surface of the foundation under the cantilever beam needs to be relatively widened. This method results in a larger separation between the foundations on the two sides, with minimal mutual influence. It is suitable for situations where there is a significant difference in foundation depth on both sides of the settlement joint, or where new and old buildings are adjacent. The third method is the cross-type treatment solution. In the cross-type treatment solution, the foundations on both sides of the settlement joint are designed as independent foundations under the walls. These foundations are cross-arranged on their respective bases to support the walls. This method has clear force transmission and good results, but it is more difficult to construct and has a high cost. In addition, there are other regulations concerning deformation joints, such as ensuring that fire doors do not cross deformation joints when opened. For more information on the construction of deformation joints, please refer to relevant specifications and atlases of deformation joint constructions. The above content covers the construction methods of deformation joints. Thank you.